second video here, and this is going to be the FM test, performance test, as well as AM modulation, FM modulation and AM modulation test. And basically what we're going to be doing is this test right here. That's pretty much what the waveform should look like once I get everything set up, which I do basically have it set up here. So let's take a look. 600 megahertz, 0 dBm, and that's the frequency domain without any modulation whatsoever. Really nice rise and fall. Looks good. So I'm going to turn on the frequency modulation right now. It's internal FM. It's modulated at 1,000 kilohertz, and the deviation will be 99 kilohertz. And this is what it looks like, which is pretty much what it's supposed to look like. All right. And then we're going to look at AM, do an AM check. So we're going to set the AM. Let's go off. I'm going to turn this off. Back here. Sorry for swinging around the camera so much. We'll do AM. Calls for 400 hertz modulation. And the depth is supposed to be 50%. And that's what it's showing right there, but I don't have the oscilloscope adjusted. I mean the oscilloscope, the spectrum analyzer adjusted properly. Okay, so we have to set this to a linear scale rather than logarithmic. So let's see, amplitude, scale is linear. Let's see, span, 0 span, and there you go. All right, and there you go. It basically should be showing a sine wave of about 400 hertz, which looks good to me. Let's change the resolution bandwidth. And that is pretty much what it should be showing. Nice stable waveform. So, from what I can tell, and there's the settings, internal AM, 400 hertz, 50% depth, 600 megahertz, 0 dBm. And this is at a 0 span, 600 megahertz center frequency, or close to it, and span of 0 hertz. So it's being modulated. That's basically 400 hertz, and it's being modulated at 400 hertz. So it appears to be working fine. Next thing I'm going to do for the next video, which this will be the second, the third will just be showing very quickly a sine wave, showing how the what the waveform looks like rather than in the frequency domain, this is really in the frequency domain. I mean, is in the time domain. This is really in the time domain right here. The previous test of the FM modulation was in the frequency domain. This is time domain. But I am going to use one of the Tektronix scopes to show how good the waveform is in the time domain, just to see, you know, how accurate if it's really a nice sine wave, which it should. You can see that is a nice sine wave, and this is in the time domain. So that'll be the third video, and then the fourth video will basically be showing the exploded or blown up, sectioned off schematics. Like I said, I basically used a poster program to expand the schematics and paste them together so they're nice and large for the low frequency unit of this of the low frequency section of this signal generator, and that was the problem. And I'm going to go through exactly what was wrong with it. It's quite a fascinating problem. Anyway, that's it for this video. All back together again. It's been running now for probably a good hour, and it hasn't smoked yet. So this is the second video in the series, and I hope it's pretty quick, about 7 minutes. And I hope you all enjoyed it. Thanks.